Hi, my name is Peter Keitler. I am co-founder and CEO of Extend3D. Extend3D is the technology leader in dynamic laser and video projection. Today, I'd like to show to you a joint demo combining Extend3D laser projection and ART tool tracking technology. The application I'd like to show to you is from the automotive paint shop, where nips and craters after painting have to be manually reworked by sanding and polishing operations in order to provide clean cars to the customer. Skilled workers used to look at the surface very carefully and touch the surface with special gloves to detect these defects. But nowadays, these defects can be automatically detected in an automatic inspection zone. So the idea is now to show the operators where the defects or where these anomalies have been detected in order so that they don't have to carefully search for them over and over again, and also to make sure that really 100% of these defects can be covered in the process and nothing is missed. These anomalies had to be found manually. Nowadays there exist automatic inspection systems, which is not from us but from other suppliers, which can identify the 3D coordinates of these anomalies on the car surface. And later on, when the car comes into the rework zone, the idea is that with our laser projection system, we can highlight and show these anomalies to the worker, and he does not have to search for them. Our system is a complementary system. We take the data from the automatic inspection system, visualize it to the operators such that they can easily and to 100% relocate these anomalies, operate on them, and make sure that everything has been processed as expected. In the real factory, the Extend3D software is connected to the conveyor PLC. Whenever a new car approaches the rework environment, the information is transferred to our software. This step I now simulate by clicking the button here in this expert software. Now the model is being loaded, and first of all we can see that in this 2D butterfly visualization we get an overview of the car with the position of all the anomalies from the different perspectives, left and right and top and rear perspective. We get a visualization in 2D, which is shown on a big screen in the environment, showing to the worker the exact locations of the defects from the different perspectives, left, top, right and rear. So what the operators really need to have is a marking on the part itself to easily and quickly identify the anomalies. And before we can show these with a laser projector, we first of all need to track the part. The challenge for the system is it needs to always know where the part is, such that it can place the laser markings in the right positions. For this we use a model-based tracking, and as you can see now on the screen, the model-based tracking has not yet snapped in. The contours are still red, but our system expects the part to arrive in a rough position which has been previously configured, and when the conveyor system reaches that position, the model-based tracker snaps in, and now the projection starts. So you can see now the laser markings right on the car door, and the operator can easily locate and operate on them. The operation itself starts with sanding, so the operator takes the sanding tool, holds it on the position to be sanded, and the laser marking at the same time changes its shape, in this case from triangle to a cross. The next step in the process is now to polish this area to make the surface clean again. So the polishing tool is now brought onto the surface, indicated by the crosses. And after the polishing operation, the laser projection disappears. switching back to the butterfly visualization, you can see that also the elements have changed in the 2D visualization. So let's finish this part and also sand and polish the remaining anomalies. Until the part is completely processed. So you see the laser projection has already stopped working, and on the 2D visualization you see that all the shapes have changed to a circle, which means that the part has really 100% been processed. This gives the workers a good feeling that they really have covered everything and not forgotten anything. And of course also it gives the manufacturers the guarantee that all their parts have provenly being processed to 100%. Nothing has been omitted. And this data can be recorded, it can be stored back in the digital twin, so the data can also later on be used for analysis to make the quality and manufacturing processes even better in the future. Thank you very much for your attention. I hope you liked this demonstration. And if you have any questions, then please don't hesitate to contact me. I'll be happy to answer your questions. Thank you very much.